Let's do this one. All right.
Mine is HDMI, but I can see the look at my computer.
Update. Yes. Run 09. All right, we're going to continue with Git.
I'm glad I missed the only day that we didn't have a lesson.
Yeah, me too.
Yeah. Are you saying your
Hey.
class clerk?
I was trying to get when we were doing our programming stuff, and it said that it was corrupt. So how do I?
What was corrupt?
I don't know. I'm waiting for it to boot up still.
Okay. We'll talk about more specific error messages. This is the Git repository that we created.
Well, no, it's the one like I created for the data stuff, you know.
What do we end
Steady
up
hand
downloading?
thing.
Oh, the one you created for that.
Yeah.
Okay. All right. So today we're going to talk about remote repositories. Everything that we've done so far has been a repository that's been local to the directory that we're working in. All of the repository information is stored inside that directory. So Git provides several tools to work with remote repositories. In fact, the old sort of source code version control model was that there was a server somewhere that was the master copy of all of the source code. And the people that were working on that could check out copies of that, and then they could check their copies back in. And it was very difficult for multiple people to work on the same thing at once. Like it would check something out and then lock that so that nobody else could make changes to it. I mean, basically the same problem that you have if you try to edit a Word document at the same time with somebody else, right? So now we have things like Google Docs, Microsoft 365 that try to manage that the whole logistics of if I've got two people that are working on the same file or set of files, how do I manage those things happening at the same time? So Git from the very beginning was designed to allow people to work on source code completely independent of each other and without an internet connection, so that you'd have a local repository that you keep all of your changes. Then how do I make sure that I can synchronize what I've made with some remote master repository? So remote repositories are just Git repositories that are stored on, well, in a different location. What's up, Patrick? Usually they are stored on another computer, meaning they're on a web server or another computer that you have access to, but they don't have to be. So you can create a copy of the repository that we created in class last time or 2 times ago, and keep basically have 2 copies of the same repository, and Git gives you the tools to synchronize those. So let's do a little local remote repository first, and then we can see how we would get a remote repository on another machine. I think I'm just going to jump straight into remote repos. All right, so if you recall, in the code directory, we created a cl-utils directory. This was our first repository that we created. So let's create a copy of that. A copy in Git terminology is a clone. So we're going to clone that repository. That repository is then going to be copied verbatim. I mean, everything that's in this repository will be in the new repository. So to clone that one, we use the git clone command. The git clone command is going to take 2 arguments here. The first argument is the repository that I want to clone. The second argument is the name of the directory that I want to put that repository in. In this case, I need to provide the second argument because I can't just make a clone of this repository that is named the same. If I had a repository on another computer, then I wouldn't need this last argument. I would just say clone it, and it would call the directory whatever it is on the remote computer. So this is going to create a copy. It says it's cloning into cl-utils2. All right, so let's go in there and look at this repository. If I run git status, it says that my working directory is clean. There's an extra bit of information now. It says that your branch is up to date with origin/master. So now there is another repository that is associated with this, the remote repository. And Git allows you to track those things. And so if I clone a repository, Git is going to automatically set up some stuff that says, look, this was a copy of a repository that came from some other location. let's track that repository as well so that you know if you need to update or push changes. So if I just open up Git K, remember Git K is the repository viewer, I get the exact same view that I got in the last class period. Apparently we made 1, 2, 3, 4, 5, 6 changes or 6 commits. Each commit has all of the information about who made the commit, at what time they made the commit, and what changes were committed. The one difference between the last time and now is that this tag up here says master, but then there's also one that says remotes origin master. And so Git will create, well, Git allows you to manage multiple remotes. If you clone a repository, it will automatically set up a remote for you called origin. That means the origin of the repository that you cloned. And so now I see where the origin, meaning the other repository's latest commit is, and where my latest commit is. Now, I just cloned it, so they're the exact same. If I run git remote, this is the commands to add, change, or view the remotes that are available. If I run git remote, I see that there's one remote listed. That remote is called origin. That's the default name for any remote that is due to you cloning a repository. So if you clone a repository, it's going to have a remote in there named origin. If I want to see some more information about origin, I can give the TAC V option, and this tells me the location of the origin repository. In this case, it's on the same file system, so it's just a directory. If it was on another computer, it would have a URL here that told me where the original repository is located. All right, so now I'm going to go back into the original repository. So I'm going to go up a directory, and I'm going to go into the CL utils. I'm going to copy another script into this. So I'm going to make some changes to the origin repository. I want to see what's required if the stuff that's from the inside the original repository changes. How do I get those changes into the cloned repository? So I'm going to copy my uncertainty script into this repository. I don't know why I'm cat in standard dev. I must have meant it's cat uncertainty. If I do a git status, I see that I have an untracked file. To add that file, I run git add with a period. Run git status again. It tells me that that file has been added and is ready to, it has been staged and ready to commit. And then I run git commit to actually put it into the repository. I'm going to use the shorthand again. Tack in with a string. We'll use that message for your commit message. All right. Now my working directory is clean and it says on master branch. There's nothing that says whether I'm ahead or behind of the origin master branch because this is the origin, right? There are no remotes set up in this initial one. So if I did a git remote, that didn't make any sense. Git remote v. Oh, that's because I cloned this from my my GitHub account. What does yours show, Derek, when you run git remote in the original?
Just git remote by itself?
Yep.
It shows origin.
Shows origin. And what if you give it a tag v?
Here, I'll type in. It shows nothing.
Shows nothing?
Yeah.
Okay. So what I've done in preparing for this is create a remote on GitHub. And so that's what's showing up on mine. Yours is probably going to show up as nothing. If you go into the CL utils 2 and you run git remote tag v, then it's going to show a link to or the directory for the original.
Which I moved over to my CL utils original. If I run git remote, it doesn't give me anything.
Okay, that's right. All right. So the cloned one has a remote set up automatically, and then the original one has no remote set up because we created that one from scratch. All right. So now if I look at, if I use git k to look at the repository, I have a new entry here. It says added uncertainty script for calculating quantity uncertainty. It tells me the time and date that was created.
which I went into the CL utils too.
Uh-huh.
And if I hit tech me on the get remote, it will then give me origin and then the direct, like the full path.
The
name.
absolute path name to
Yeah,
the
absolute
directory.
path name.
Yep.
And it'll say fetch and push
Yep.
afterwards.
That's for fetching and pushing.
Mine get remotes, not get remote again.
In either one,
Yeah, go over to the second one because
it should only show something in the second one, the one that you cloned. That's the only one that will have one set up automatically. Okay. All right, so I just looked at the repository in the original one. Now I'm going to go into the second one. Right, this is the cloned one. And if I run git status, it says that my working directory is clean. I run git k. I see that the last commit that I just made is missing. There's no way for this repository to know that something has happened in the other one. Right? They're completely separate from each other. Git provides commands that allow you to explicitly communicate information back and forth between them, meaning like if there are commits on the original that you want to pull into the new one, or if you've made new commits in the new one that you want to push back to the original, Git provides the framework to do that. But right now, there's nothing here that even indicates that another commit has been made. Now, this relationship where we've got this original repository that we made and then we cloned it, typically what you'll hear people say is that original one that we cloned from is called upstream. Right? So that's upstream from your repository. You would be pulling commits down from upstream if you were trying to keep track of commits that were being put into a repository. So in this example, it's not very practical. You're not going to create a remote repository or create a clone of a repository on the same machine. But when we move to GitHub, the GitHub will be a remote repository that we can pull commits from. All right, so the git pull command takes an argument, which is the name of a remote. And this is the name that Git uses. So there's a URL for the remote, and then there's a name. So if I do git pull origin, it's going to check to see if there are any newer commits on the origin remote, and it's going to pull them into this repository. And if there are commits to be pulled in, I should see something like this, right? It says counting the number of objects, compressing them. It's trying to determine what needs to be copied. It only copies the stuff that needs to be copied. It doesn't copy everything again. It just copies the stuff that's different, and then it updates it. If I run git k now, I see that the added uncertainty script for calculating the standard error of the mean has been added. So now I've synchronized the they're basically, I've synchronized the secondary repository with the original one that I created. Yes, Jordan.
So if you went in there and changed the name of all the files that were in the sub-git,
Yep.
Then you went and replaced everything, would it just add to it, or would it replace it back?
It would replace them. Yeah, I mean, so if in the second repository you make changes, and then in the first one you make changes, and you try to do a git pull, it'll try to merge those. And then the end result, if it can do it automatically, will be to try to make a combined version of both of those. If you want it to keep both of those files, then you'd have to merge the files manually. But it does a pretty good job of tracking renames. So if you change some files in the original, and in the second one you just renamed it, Git can usually figure out that that's what happened and actually merge those changes. All right. If you are working on like some code for a project, or you're working on a LaTeX paper, something like that, and you want to say, all right, well, I know that this works, so I'm going to try to make some changes to see if I can improve this, but I don't want to do anything that would mess up what I've got, because I want to, if I have to, I'll just turn this in for the homework. You don't need to create a clone of your repository and then start working in the clone, right? You can keep everything in a single repository. And the way that you do this without messing up work that you know is good is you create a branch. And so Git allows you to create branches, I mean, very simply. That's one of its most useful features, is that it's absolutely trivial to create a branch. So let's say that I know that I've got all of these scripts and they work. Now I want to try something that I'm not sure will work, but I don't want to break the scripts that I have. So the scripts that I have are on the master branch. If you look through some of these previous, like the get status here, it says on branch master. That's because by default, Git creates a branch for you, and it's called the master branch. Let's say I wanted to make some changes that I weren't sure were going to work. The first thing I would do is I would create a new branch. I'm going to call this branch experimental. Then I would check out that branch. So now I'm switching my working directory to this new branch. And anything I do in here will not affect the master branch. I can always go back to the master branch, which should contain stuff that I know is good. So for example, let's say I remove the uncertainty and the standard deviation scripts. I run git status. It tells me that I have 2 files that are deleted. Let's add those deletions and commit that. Git status now says that my working directory is clean. If I just list the files, I can see that those 2 files are gone. If I run git k, I now see this latest commit that I just added, but I see a green little bar here now called experimental. So these green tags are branches in your repository. I have a master branch, which is right here, and I have an experimental branch, which is right here. So if I check out the master branch again, it will go back to the same state that it was before I started making these experimental changes. So even within a repository, you can basically have multiple lines of work so that you always know that, well, if I go back to my master branch, I have something that I can actually turn in for homework. And then there's all kinds of different workflows that are built up around this. You know, probably for everything that we're going to be doing up to this point, just using the master branch is fine. You know, most projects use branches extensively. So if you want to add a new feature to some code that you're working on, you create a branch, you implement that feature. Once you get that feature ready to go, you can merge it back into the master branch. And Git provides all of the tools to do that. So I'm going to check out the master branch now. And if I ls tac l, I see that the standard deviation and the uncertainty scripts are both there. So that's exactly as it was before. If I run git k by default is just going to show the history from the branch that you're on. Now, since the master branch was an ancestor, meaning I created the experimental branch from the master branch is has an older snapshot or is an older snapshot than the experimental branch. That showed up in the experimental branch's history, but the experimental branch doesn't show here because that is not something. There are no snapshots in the experimental branch that are older than master. Well, none of the new ones are. Now, if I had the experimental branch to the point where I was like, okay, these changes work, now let's bring those back into the master branch, I use the merge command. So git merge experimental will take all of the changes that I made and bring them into the master branch. This is an easy update to make, but if I had been making changes to the master branch as well, like if I had found bugs and I was bug fixing stuff, and then I was making all of these changes in the experimental branch, git merge will try to combine those two so that I don't have to do anything special. So if I do a git merge experimental, it tells me that there was a fast forward. That basically means that there weren't any changes in the master branch that had to be merged with the experimental branch. I run git k now, and I see that the master branch and the experimental branch point at the same commit. So now they're at the same place. And both of those are ahead of the master branch in the origin remote. ls tac l, and I see that those things are gone. Now, even if I have a master branch that has those deleted now, I have an experimental branch that has those files deleted now, I can still, if I find out that something bad happened, like in this case, I deleted files that I really needed, they're still in the repository. They're not lost. You can always extract them from the repository. So the way that I would go about doing that and this is something that doesn't come up very often. So when it does, you're basically going to look up, how do I recover lost files in a Git repository? But basically, I do this. The reset command says reset the master branch to some point in the past. Now, there's a special tag here named head, which basically means whatever the last commit on the branch is. And so this is a reference to head, and then this little caret means one commit before head. So we know that head, the tip of the master branch, now contains a commit that deleted 2 files that we don't want to be deleted. So I'm going to reset this to the commit right before that, where I know that those files exist. And so it says that it's unstaged changes. And then the next thing that I need to do is, remember, if we deleted something before we committed, we could always do a git checkout period, and that would check out all of the files that are in the current snapshot. So that's what we're doing here. We basically just took the master branch, reset it to a commit that we know is good, and then we're going to do a git checkout period to check out all the files in that commit. And now those files are back. So you really don't have to worry about losing work as long as you're committing your work often. And if it's in the repository, it can always be extracted. If you don't, if it's a long ways in the past, or maybe it's not an ancestor of head, you can also do a git reset and use these numbers right here. This SHA-1 ID, you don't even have to use the whole number. So if I did a git reset and just copied those numbers in there, Git would reset the current branch to whatever that commit is. If you go through each of these commits, they all have different SHA-1 hashes. So you can identify it, and that's exactly how Git identifies each of them. You can identify it with this thing here. So if I knew that this is the last one that was good, and I wanted to go back to that commit, this number, I could do a git reset that number, and then do a git checkout to bring myself back to that state.
Sure. You definitely can get tools right at the same time.
All right, here we go. So open up Firefox and go to github.com.
It's not wrong.
github.com.
Oh, GitHub.
Yes.
github.com.
GitHub.
Make sure you spell everything right. Dangerous territory.
Yeah.
What do you mean?
Make sure you start with soup.
It's going to look like this.
Yeah.
If you see some yellow, you're on the wrong site. Should we sign up for GitHub?
Not yet. Let's do a search. So one good reason to know how to use Git is because there are many projects now that are posted on GitHub. And so it's very common if you want to try out something that's not in the like the Debian repositories or the Mint repositories or the Ubuntu repositories, meaning if you can't install it with apt, you can just go get it off of GitHub and install it from source, as they would say. So let's do that with one tool, GSC. So let's search for GSC and see if we can find, yes, this one right here, CD3 GSC. This is my guided shell scripts tool. Okay.
C++.
Oh, is this what you
Yep.
use to run all your stuff?
Yeah.
Where it types for you?
Yeah, so let's download that, compile it, and check and see if we can get it to run on our computer. So click on this link here. This is the project page for GSC, which is guided scripts for the command line. It's got some documentation here. One of them tells you how to download and compile it. So let's do that. So you can see the git clone command is used to clone the source code. So this is going to be a remote repository. This one is actually on a different computer. So we give a URL to the git clone command. There's a shortcut if you don't want to type it all out. There's a button right here, clone or download. If you click on that, this button will copy that to the clipboard so you can just paste it into your shell. This HTTPS URL is the exact same as the URL in the browser. So you can also just copy and paste that.
So does it matter where we put this?
No. I mean, wherever you run this, it's going to create a directory in that directory. So, maybe you run this from the code directory or something like that.
Did you write this?
Yeah.
It's about CD3.
Yeah.
All right. So I'm going to git clone and I'm going to type in the URL or paste it. Typically, I would just paste it.
Call it GSC.
If I run ls-tacl, it's GSC, so it creates a directory named GSC. Let's go into that directory. All right, now if we read the instructions, after we get into that directory, we need to create a directory named build. We're going to go into that directory, and then we're going to run cmake with a ... You're probably going to get an error message that says cmake is not installed. So just install it. Then we run make, and then we run sudo make install. So we're going to create a directory to compile the code in. We're going to go into that directory. We're going to run cmake to generate the build configuration. Then we're going to build it, then we're going to install it. Do you guys use cmake, Patrick?
Does that like generate the make?
Yeah, it generates the make files, but what's really nice is that you can also tell it to generate Visual Studio project files if you want. Hey, at least you don't have to do them by hand. If somebody wants them, it's trivial. It'll do Ninja config files. Ninja is like a parallel version of Make that Google wrote.
What does CMake do?
CMake.
So
CMake generates like build files, like make files.
Because I just tried to put that in. It's like the program CMake is not currently installed.
Are you even here, Derek? I just talked to him for 2 minutes about what CMake is, and Corey just said the program's not installed. I said, if it's not installed, install it. Man, you get in the zone. And you
I get in the zone. You should see me in like linear. I'll be working on something the entire class period, and I'll look at me.
linear.
Corey,
You'll
you
be
better
on
not tell me
Tumblr
that
the
it
whole
says that
time.
CMake's not
I read an
installed.
entire paper in there one day.
All right.
We need to install make as well.
Is Make not installed?
Yeah.
No?
But
Yes, you need to install Make. What's that?
Where are the dependencies of your program?
There aren't any. It'll look for them.
Mine's not making this. See,
Oh, I'll bet it does require boost.
I think that's what it is. It's just
So when you run CMake, what does it say about the dependencies?
configuring incomplete errors occur.
Yeah.
Like we don't have make. Yep, it's boost.
Missing destination file operand after CMake.
So when you install make.
Following variables using
Mhm.
project there set to not found. Please set them.
All right, so I'll do a make install. I do need to run sudo because by default, this is going to try to copy it to a directory that I don't have write access to as a user. So I need to give my password for that, and it says that it installed it into user local bin. All right, if you run GSC TAC-H now, you'll get the help message for GSC, which is basically the manual. All of the stuff of what it does, like what options it takes, how to control its behavior is all contained in here.
What was the last command you typed?
GSC TAC-H.
Whoa, finally.
You must not have gotten it installed. Did you run sudo make install?
Yes.
Did it say that it copied it into user local bin?
Yes, home, username, install.
So is this like a man page for it?
It's basically, yeah, it's the manual. It's the help message.
You got that message?
Right after you run make, you run sudo make.
Type in GSC.
Same place. You just, wherever you started this at, do that. Then same place. I didn't move at all, and it worked perfectly fine.
Did you type in scenic fix dot com? Yeah, you do. Yeah, go with the directory,
No, period.
delete the build directory, and then start from there.
Sudo big install.
Noob.
Okay.
Jeez, can't find
So-
it. Okay, so try it.
I've got the problem that.
Go to the webpage, so he has to pull up, and it literally has the step by step. That's how I did it.
Doesn't have a patent in it.
Well, I think I'm ahead out.
Other,
No.
Oh, I got some steak.
Just run a dot slash GSC.
Hey Joey, don't forget that we're not going to win next Monday.
So build,
Why is that?
So we're gonna go watch the.
you just can't copy it to a directory where you can use it as a.
Say I was going to that.
Oh, that's fine.
Yeah, that's that.
All right, so let's go run this as an example tomorrow.
Wow, so much is going.
Is our final project going to have to use this and eSpeak, so that it just speaks the entire
Teaches
presentation?
a lesson. We gotta do a lesson.
Yes.
We're giving a presentation in realities class. I wonder if they'll mind if I just use eSpeak to give the entire thing. Just lock the